Yeah, Camson is wrong. Let's start off. Anyone got the answer for this? No answers. Let's see. And I told you also the hint is there in this problem in basic maths and vectors. The coordinates, you'll get it from here. So page 58 vectors. Let's see how to use that. 4r1 minus cos theta by 2. Yeah, Ahana, you got it. So it is here, and then when it comes here, so initially point A is here, and the point A comes here, and you rotate it by angle theta. You can refer page 58, basic maths and vectors. There I taught you how to find coordinates. So if a wheel rotates one complete revolution, you will go 2 pi r. If the wheel completes theta angle, then this distance is r theta, remember? If that is r theta, this is theta here, and this distance, this would be r cos theta. This distance would be r sine theta. Then this length will be r minus r cos theta. So A ka coordinate will be r theta minus r sine theta. So from here we get x coordinate of A is r theta minus r sine theta. The y coordinate is r minus r cos theta. Is this clear, everyone? This we have done in vectors, the coordinates. All got this? Others, do keep your cams on. Great. Next thing. So we have r is theta minus sine theta. Y is r into 1 minus cos theta. Now, if I differentiate this dx by d theta, this would be r 1 minus cos theta. If I differentiate this dy by d theta, this would be r 0 minus of cos theta is minus sine theta. So from here we get dx would be r into 1 minus cos theta d theta, and dy would be r sine theta d theta. Now, if you remember the distance formula, for distance I gave you two formulas. Remember, integral mod v dt or integral root over 1 plus dy by dx whole square into dx. I told you this. You can use this if you know x and y. So if you send dx inside, this will become root over dx whole square dy whole square. Remember this? We did this here. This guy. Actually, if you see it, we derived it from here only. You send dx inside, you'll get back the actual form. Root over dx square is dy square. Now substitute dx and dy. So this is integral root over dx would be r 1 minus cos theta d theta ka square r sin theta d theta ka square. R will come out. Left out with integral root over 1 minus cos theta square plus sine square theta into d theta. Limits will be from 0 to theta because you're rotating by theta. If I expand this, that inside you'll get 1 plus cos 1 minus 2 cos theta plus cos square theta plus sine square theta d theta. That turns out to be r root 2 integral root over 1 minus cos theta. I'll show you in the next page. Have a look at till here. Any doubts till here, please ask.
Sir.
Hmm.
Sir, so when we're asking, like, in the question it was asked v dt, but here we've got v d theta. Sorry, d theta actually. So,
What did I ask in the
sir,
question?
so you asked mod v dt.
Where did I ask?
Oh,
What did I ask in the question?
okay, sorry, sir. Sorry,
No,
my
what did I
bad.
ask in the question? I'm just asking you, what did I ask in the question?
Sir, no, I wrote something down.
What did
Something
you
else.
question तो है ना find distance पूछा था.
Okay, sir, sorry.
The distance is both the formulas are valid ना. Turn in the page. The problem with mod VDT finding that V bar it will be quite complex. You can, but it will be complex. So this
Yes,
will be
sir.
R root over. So take out 2 common, you end up with 1 minus cos theta d theta. And we know 1 minus cos A is what? 2 cos square A by 2. Hope you remember the trigonometry formula. This would be R 2 cos A cos theta by 2 d theta. ये साइन होगा, sorry. This would be 2 sine theta by 2 d theta. So 2r integral sine theta by 2 d theta 0 to theta, and this integral sine ax plus b dx का integral is minus 1 by a cos ax plus b. So in our formula here, a is half and b is 0. So that would be sine x by 2 dx का integral is minus 2 cos x by 2. So this would be 2r minus 2 cos theta by 2, limits will go from 0 to theta. This would be minus 4r. Cos 0 is not 0, huh? Cos 0 is 1. So we get 4r into 1 minus cos theta by 2. You can further simplify this. 1 minus cos theta by 2 is 2 sine square theta by 4. So the answer would be 8r sine square theta by 4. That would be a final answer. If someone got till here, you're right. You're not wrong. You can just further simplify. That would be your distance. The final answer looks neat. Again, look at the whole thing what we did. First we found the coordinates, then we found dx and dy, then we dumped it in the distance ka formula. Once you're done till here, physics got over. After that is just brute force max. There is nothing there. Just put there, simplify, integrate, and done. Do look at the steps.
So could you show the previous page once again? Thank you.
Anyone else? Any doubts on this? Please ask. That means when this guy is going in a circle, so this is a more of a standard result. In an exam like bits or means or something, they'll ask you. So if you look at this point here, in one complete revolution, A would go something like this. This is the path of A. So exam they'll ask you this. Find the distance traveled when the wheel rotates one revolution. So 8r sine square theta by 4. For one revolution, theta is 2 pi. So that would become 8r. But most people get confused with this. This would be the displacement, the distance between initial and final point. Displacement is 2 pi r. Be careful with that. They'll ask in the exam, a wheel rotates 1 revolution, find the distance traveled by A. Most people will write 2 pi r and come, because that is not the distance traveled, that's the displacement. Answer is 8r. It travels 8r distance. Getting it? So that would be a straightforward question in an exam like bits or mains. The standard result, we proved it for an angle theta. So definitely mug up the result. Have a look at this. All clear with this? And where did you guys get stuck exactly? Vihan, what did you try?
Sir, I went all the way till the integral, but then the d theta dt problem started.
Then others, Ishana, what did you do?
I didn't. I forgot to this homework. So
Forgot only. Others, Daksha, Arya, got any ideas? Didn't get how to start. Not an issue. It's a good one, but this would be a proper advanced level problem. So this is the kind of thing. See, I'm not expecting like you guys will get it, but when you try to do these kind of things, right, your level goes up. You'll get used to the difficulty. Great. Next thing, uniformly accelerated motion. This is something which you have done in foundation also. I hope this time paper mein there are no doubts. Did you find any corrections? So what is uniformly accelerated motion? So in a uniformly accelerated motion, we take the acceleration to be constant. So the three equations we derived is in integration, if you remember. V is u plus at, S is ut plus half at square. V square minus u square is 2as. So be very careful. Use them only if you are sure acceleration is constant. Later on, we're going to see when a is not constant. So here u is your initial velocity. V is final velocity. S is displacement. T is time. So displacement is nothing but the final position minus initial position. So here we have a sign convention. We take right positive, up positive, left negative, down negative. Keep it simple. In school, right? Sometimes in schools, they teach you like this in the direction of acceleration positive. Forget about all that. Keep it very simple. Up positive, down negative, right positive, left negative. This is what we're going to use for most of the mechanics. Once you guys get used to it, maybe then you can modify it. But for now, keep it simple. You're already learning a lot of new things. Unnecessarily don't bring more confusions. So let's say if u is going this way 2 meter per second, and let's say acceleration is going back with 1 meter per second square. Then in the formula, when you use, put u is equal to plus 2 and a is equal to minus 1. So when you use the formulas, you have to put them with the signs. Let's say if u is going with 4, and let's say acceleration is 3 meter per second square. So when you apply the formulas, put u is equal to minus 4 and a is equal to minus 3. the signs should be taken. Put it up. Just have a look at this. There, these are the three main formulas. So today we'll be dealing with the horizontal motion. Next class we'll do vertical, and then we'll do variable acceleration problems, and then we'll start off with projectile. Yeah, you can stick to one sign convention, na Vihan? Anything that you like. This is something which I would follow, so I'm saying let's stick to this. But if you think you have something other which you are comfortable, use it. Nothing wrong. Just don't do a khichdi of both the sign conventions, and just be careful with that. That's the thing. If you follow 2-3 things, that's what will happen. Fix to one. Clear? Let's see a question. Let's do an easy one. So we have a vehicle here which is going with u is 2 meter per second. Acceleration is 3 meter per second square. This is the time t is 0. Find speed and displacement at t is equal to 5 seconds. Find time and speed when s is equal to 20 meters. Find ratio of distance traveled. Third second and 3 seconds. They're completely two different things. When you say third second, now see like this. If you're going from 0 to 1, 1 to 2, 2 to 3, so 0 to 1 is called first second. 1 to 2 is called second second. 2 to 3 is called third second. So when someone says third second, what they mean is you're talking from t is equal to 2 to t is equal to 3 is called third second. If someone says 3 seconds, you're going from 0 to 3. So 3 seconds is simply t is equal to 0 to 2 is equal to 3. So be careful with that word. Second, second, third second, and 3 seconds, the whole answer is messed up. It's a completely different things. Get them. Simple formula substitution. There's nothing there. First two questions at least. Hmm, 95 by 2, 1939. Huh. Try. I'll give you a minute. I'll show you the first two parts in one go. Let's see. The first one is easy. You just need to see always what is being asked. You know initial velocity, you know acceleration, time is given, you want final speed. So it is pretty straightforward. We have to use v is equal to u plus at. So u is 2, a is 3, and this is 5. So this is 17 meters per second. Then displacement is ut plus half at square. 2, 5 plus half 3, 5 square. That would be 10 plus 45 by 2. Speed is 2, a is 3 now. That is 75 by 2. Yeah, that is 95 by 2. Yeah, or 47.5 meters. Same thing. What about B? Time and speed when S is 20. So S is ut plus half at square. This is 20. Speed 2t. Acceleration is 3t square. You got a quadratic. 3t square plus 4t minus 40 is 0. So t is minus 4 plus or minus root over b square 16. 480 by 6. You can leave it here. Or it is simplify. And take the only positive root, don't take the negative root. And you want speed v square minus u square is 2as. So v square and 2 square, 2 acceleration 3 and 20. It would be 120, 124. Yeah. Check it out. Nothing there, just direct substitution in the formulas. Get the last one.
Sir.
Alright.
Sir, in the exam, are we allowed to substitute 124 for 121 and get 11 meters per second?
Depend on the option, right?
Yes,
It is a single, is the option questions, na? They will give something like 11.2, 12, and 13 and 14, let's say. That too you can feel it, right?
Yes.
But if it's an integer question, you have to type, they'll expect you up to 2 decimals, you have to get it right.
Okay, sir. And
So
sir,
it depends
if
on the type
we,
of question.
sir, if we find v, then can't we find t using that
You
v
can
equals to
find,
u?
you
So
can do,
then
but
it's
I'm just
easier.
doing, assuming I don't know the other one.
Okay.
I hope everyone has no doubts on A and B part. Direct substitution. Still confused anyone, please ask. Yeah, you can do that, Vignajit. You won't get a quadratic, but I am assuming I don't know time and then I'm doing this. Logic wo tha. But okay, same thing. Get the third one. I'll give you a minute. Yeah, one answer. Find the ratio of distance traveled in third second and 3 seconds. Right, Ansh. We have Ahana, 2 answers. Others, try. Let's see. Yeah, right, we have. Now the distance traveled in 3 seconds. So I will go from 0 to 3. We are using the formula ut plus half at square. Two into 3. 3 into 3 square. That would be 6 plus 27 by 2. That's 35 by 2. Now you are asking from third second. Third second is nothing but, can I say like this? Go from 0 to 3, subtract 0 to 2. Calculate from 0 to 3, calculate from 0 to 2, and then subtract them. That should give you 2 to 3, no? So if you calculate from 0 to 2, that would be 2 into 2 plus half into 3 into 2 square. Thus would be 4 plus 6 is equal to 10. This would be 35 by 2 minus 10. That is 15 by 2. Did I goof up something? I goofed up something. This is 39. This is 19 by 2. So third second, 3 seconds. The ratio would be 19 by 39. Check it out. Okay. Now I know there's a formula for an nth second. So let's see that also. But the thing is, you should know how we got it also. Don't just blindly remember the formula, because suppose they'll ask a question like this. Find the distance traveled in the 7th half second. They did ask something like this once. What do you mean by 7th half second? So if you see this thing, 0, half, 1, 1.5, 2, 2.5, 3, 3.5. So this is the first half second. Second, third, fourth, fifth, sixth, seventh. Matlab 3 to 3.5, na? So they did ask something like that, 7th half second. What people did, they kept this formula in that half second ka formula and finished it off, and everyone got a wrong answer. So remembering a formula is good, but you should remember when to use and when not to use. If you blindly use the same thing everywhere, you'll be trapped. So if you look at the nth second ka distance, so nth second would be Sn minus Sn minus 1. So this is un plus half a n square minus un minus 1 plus half a n minus 1 whole square. Expand this. This will be un minus u. You will notice this. This guy will cancel. This guy will cancel. You'll be left out with u plus n minus half. That's your answer. This is the distance traveled in nth second. Meaning you'll get only time interval between 1 second. If you try to use this for the 7th half second, so what people did, they kept this as 7th half second and tried. You will mess up. You won't get the answer. Yeah, so this is a general formula, but yeah, it's not difficult. You could have found it anyways. Have a look at this. Clear? next thing. Next one. Turning the page. Any doubts, please ask. Janil, clear with this. Pratik, Nikhil, Vignajit, Prashank. Perfect. Next one. We have two trains, A and B. Both are on a parallel track. So train A starts with an acceleration A1 and B starts with an acceleration A2. They travel for some distance. After time T1, no, they won't be at same distance. So after time T1, this guy became A2. The accelerations became reversed. A1, A2 got exchanged. Two trains, A and B, on parallel tracks. Have acceleration A1 and A2 for time T. Then accelerations become A2 and A1 for another time T. Meaning, if I give you numbers, it will be like this. Train A is going with 1 meter per second, B is going with 3 meter per second for 1 hour. Then A goes with 3 meter per second, B goes with 1 meter per second for another 1 hour. So total they travel for 2 times, 2T. So the question is find ratio of the distance traveled, that is distance traveled by A by distance traveled by B. The total in time 2T. So in time 2T, find the ratio of the distance traveled by A and B. Then whatever this ratio you get, SA by SB ka range. Range meaning what is the maximum and the minimum value of this range. Because if you see, your answer will come in terms of A1 and A2. So for that SA by SB ka ratio, what is the maximum ratio? What is the minimum ratio you can get? Let's get this. Nee, rate is not 1:1. Don't mug up the answers, God. Solve. How the hell did you get number? There is A1 and A2. I know we did this in the foundation. It is not that question. This is something else. I gave exam. That was A and 2A. These are A1 and A2. Don't get confused. Try. Initial speed, we said starting from rest, na? No. So, starting from rest. So, yeah, initial speed is 0. Right, Vihan. That is right. Right, Ishana. What about the range? Let's see. So the most common mistake here is people think the speed is zero in the second part of the motion. See, look at first A ka train. So your initial speed is zero and your acceleration is A1. So the train will go somewhere till here. We are using the formula S is equal to ut plus half AT square. U is zero. So this guy would be half A1 T square. So when the train reaches here, by now it has already gained some speed. V is equal to U plus AT, U is zero. So A1 T. That is the catch. And the train acceleration became A2. So in the second part of the motion, so the final speed in the first part is the initial speed for the second part. So the second part of the motion, you're not traveling with zero speed. So S is ut. U ka place mein you have A1t into t plus half A2t square. So if you have chosen this to be zero, you will get 1:1 answer. So the total distance traveled by A, add them up. Half A1t square, A1t square, A2t square by 2. This would be 3 by 2 A1 t square plus A2 by 2 t square. The same thing if you do for B also. Initial velocity is 0. Acceleration is A2. This would be half A2 t square. So when the speed particle reaches here, the speed has become A2t. So your initial speed is this and acceleration has become A1. Now this distance will be initial speed is A2t. So ut plus half A ka placement became A1t square. So the total distance traveled by B will be, add this up, you get 3 by 2 AT t square plus A1 by 2 t square. So now you want the ratio of SA by SB. You can clearly see there, if you just take out t square by 2 common, you end up with 3A1 plus A2. T square by 2 common, you end up with A1 plus 3A2. 3A1 plus A2 by A1 plus 3A2. Check, that's your answer. Right, Ishana. Then what to do? Now we need to find the range of this. Let's see the range part. Any doubts on this page? Now look at the second part. So that SA by SB, we got a 3A1. So take out A1 common, multiply and divide by A1. You end up with A2 by A1, 1 plus 3A2 by A1. So multiply and divide by A2, A1 and A2. Now here, if A1 is much, much larger than A2. Let's say the train 1 initially accelerated with very huge acceleration, let's say like 10,000, and that is 0.01. Then A2 by A1. So see, just understand what you're doing. A1 is a big number. So if you divide a number by a very big number, this number will tend to 0. Isn't it? The number will tend to 0. That means your ratio SA by SB will be approximately equal to, that is a symbol, approximately equal to 3. This guy will be 0 plus 1 plus 0. So this is equal to 3. That means you do anything you want, you cannot exceed 3 ka value. Similarly, I can do the reverse. Divide by A2, so 3A1 by A2 plus 1. A1 by A2 plus 3. Now this time do the reverse. A2 is much, much greater than A1. Meaning if the train 2 is going with huge acceleration, then A1 by A2 will tend to 0. In this case, the ratio SA by SB will be approximately equal to 1 by 3. Means you can put any values you want. The value will never exceed 3. The value will never go below 1 by 3. Don't put equal to sign because it tends to 0, but it will never become 0. Means you know what? Suppose this train ka acceleration, if I give 10 lakhs, and if I give this acceleration 0.00001, even then the value will not exceed 3. You give any numbers you want, you cannot exceed value of 3, or you cannot go below 1 by 3. Is that making sense, everyone? Have a look at this. Clear? Next one. Next one. So we have a vehicle going with VA 20 kilometers per hour. B is somewhere here, C is somewhere here. BC is 50 kilometers per hour. And it is given this ratio AB by BC is 1:3. A vehicle moving in a straight line with constant acceleration. So we know it is going with constant acceleration. How much not given, right? And the distance ka ratio B is given. So the question is, so if you start at A with 20 kilometers per hour, and if you reach C with 50 kilometers per hour, so when you're at B, what is the speed? Get it? Easy one. Get this, just give it a try, get some water and come. Root 925. Yep. We have 2-3 answers. Root 925, everyone. Vignajit, Ahana, Ishana, you all got it. Devansh, you also got it. 5 root 29. Someone simplified it for. Let's see. So if I take this distance to be S, this has to be 3S because it is given 1:3 ratio. So if you take from A to B, so here A is initial and B is final. So we are using the formula V square minus U square is 2AS. So VB square minus VA square is 2AS. So when you go from B to C, your C is final and B is initial. This would be 2A3S. So this is equation 2 and this is equation 1. So just divide equation 1 by 2. You get VB square minus VA square by VC square minus VB square would be 1:3 ratio. Cross multiply. 3VB square, 3VA square is VC square minus VB square. You end up with VB is equal to root over 3VA square plus VC square by 4. You substitute the values, you end up with root 925 kilometers per hour. Check. Easy? Clear, everyone? Next thing. Next thing. Clear now, everyone? Abhinav? Clear, right? Great. Next thing. Similar questions we have done in some of them in foundation. If you remember it, great. If you don't remember, that is fine. We are doing it anyways. So we have a vehicle here going with U is equal to 10 meter per second. Acceleration is 2 meter per second square. Find the distance traveled in 15 seconds. Standard questions. So I told you this last class. When you hear the word distance, you should have some fear. Bihan, you're right. Ansh, you're wrong. Arya, wrong. Nee, Daksha. Distance can't have a direction.
I haven't said that.
Not you, sorry, Daksh. Nope, it's not 100. Right? How are you guys getting 100? 75 is wrong. 100 is wrong. 375 is wrong. $20. How the hell you got 20, God? 20 the highlight only. Shit, right? You guys are getting every number. Let's see. 600. I'm sure you guys are joking now, right? No. Okay. Now the catch here is, if you do this thing, S is equal to ut plus half at square. If you have done this directly, you'd have ended with 10, 15. The acceleration is backward, so -2, and that is 15 square. You would have ended with 75 meters minus. Remember, this is displacement. S is equal to ut plus half at square. S is displacement. It is not distance traveled. Last class we did a more, dangerous version of this. This is an easy part still actually. Whenever you want to do this, how do we start? Find the point where it comes to rest. So initially t is 0, you're at x is equal to 0. So this guy is going front and somewhere here it is stopping, v0. So v square minus u square is 2as. v0, u is 10 square, 2 minus 2 into s. S is 25 meters, meaning this guy is traveling 25 meters forward and then it stops. Then it takes a turn and comes back, and finally you reach minus 75 meters. Isn't that the meaning? You started at 0, you stopped at plus 25, and then after 15 seconds you're at minus 75. Means how much did you travel? Means first you must have traveled 25 meters front, then you must have traveled 25 meters backward and you came back to origin, and then you traveled 75 meters backward from origin. And that was the reason. Displacement is only coming 75, no? Because displacement doesn't care how much you have gone ahead. So therefore, the distance will be how much? The total length of the path, which is 25 plus 25 plus 75. 125 meters. Check. And last class we did even a more dangerous version of this. This guy, it was going front, back, and then again front. This was even more deadly. Clear? This thing is like a tiger. This thing is like a cat. Wo bhi street cat. Easy one. Check it out. I don't know why you guys got 600. That was a surprise. Someone got 20. Few people did get 125. All clear with this? Easy one. Next one. Next one. This we did in the foundation. Let's see whether you remember. We have a plank. We fired a bullet with speed u. It enters and it comes out with 19 u by 20. I didn't even change the numbers. But anyways, it is fine. Try. So the question is, bullet enters and leaves the plank, losing 1 by 20th of its speed. Assume constant deceleration. So assume the wood is offering constant deceleration. The question is, how many planks are needed to stop the bullet? Someone does remember the answer. Solve. Let's see. Because if you don't know how to solve, then second time I will say it is 17 u by 20 and then you will get trapped. So solve. ये boards तो नहीं है ना, boards में तो things repeat. How many planks are needed to stop the bullet? So you enter with u and you want the bullet to get stuck here. Let's get this. Right, Ahana. Yeah, most of you got the answer, I know, but solve. I hope you solved it and got it without guessing or remembering. We are not a memory competition class. Let's solve. Niharika, but you have to round off the thing, no? You can't have this thing. Yeah, answer is 11. I'm sure most of you did get it by solving. Try. I'll still give you a minute more, then I'll show you. Yeah, let's see. So you are entering with u. You're coming with 19u by 20. Let the width of the plank be d. So using the equation v square minus u square is 2as 19u by 20 square minus u square is 2 into a into s. when you have n planks, the distance becomes n into d. You are entering with u, and velocity is 0. So now if I write the same equation, v square minus u square is 2as, this time would be 0. U square, this will be 2a n d. So take this 2ad and substitute here. You end up with u square is equal to n, and 2ad will be 19 square u square by 20 square minus u square. You get n is equal to 20 square by 20 square by 19 square. This is 400 by 39. This is approximately 10.25. Means we need 10 planks and a 1/4 of a plank. Means we are using the 11th plank. 10 plus 1/4 of a plank. If you use only 10 planks, you'll still come out with some speed. Therefore, n is equal to 11. Easy? Hope you remember. So if you see, we used only v square minus u square is equal to s. We didn't use any multiple equations here. Clear? Next one. Next one. We have a vehicle here whose speed is 20 root 2 meters per second initially, and you're accelerating with a. A is not given. So the vehicle accelerates to a speed of 60 meters per second. And then, so once you reach 60, then the acceleration reverses. So once you hit the speed 60, suddenly this guy started reversing, the acceleration reverses. Means you can say applied the brakes or the engine started becoming reverse. Magnitude is same. Same magnitude, but that A became left now. Find the speed when it reaches the initial position. I hope the scenario is clear, everyone. You're starting with 20 root 2. You started going faster and faster, and suddenly your speed became 60. At that instant, you just reverse the acceleration. And you came back again to the initial position. So in this process, find the speed when you come back to the initial position. No, Surya, that's not the answer. Devansh, you are right. Nevihan, that's not the answer. 20 root 2, nahi re, it won't come back with the same speed. You guys are goofing up a sign eggs. Right, Ahana. Nee, Vignajit. Try. Another 1 minute, I'll show you then. Right, Ahana, you got it. Let's see. So the thing here is you need to understand one thing. The vehicle, right? Starting with 20 root 2, acceleration is a fair enough. So once you reached here and your speed became v is equal to 80. Sorry, 80 volt wrong. V became 60. Your acceleration suddenly reverse. Do you think it will suddenly turn back? No, right? It will continue to go forward. Na? It will go forward, it will stop, and then it will turn back and come back. So when it comes back here, this is your V final, which I want to find. I hope you're getting it. Now in this process, let this displacement be S. So if you write the equation there, so we are using V square minus U square is 2AS. So that is 60 square minus U square is 20 root 2 square is equal to 2AS. So we get 2AS is equal to 3600 minus 800, 2800. Now, when you're going from here to here, look at this. In the formula, S is what? Displacement, right? So do I care how much you have gone ahead? We don't care. So if you look at this, your speed is 60. Your acceleration is backward. You went front and you came back here. This is V final. This displacement is still less. So when I write the equation, V final square minus 60 square, 2, be careful with the signs. A is negative because it is backward. Displacement is also negative because initial to final, look at the arrow. The displacement is also backward, minus S. Isn't it? You're starting here and you're going back. So both the displacement and the acceleration are negative. So V final square will be 3600 and 2AS is 2800. This comes out to be 60, this thing. So V final is 80 meters per second. Clear with this? Any doubts on this?
So
All right.
I calculated it like the distance it does for the whole round, but I still got the same answer.
Fine. No? You're not wrong. You're just long.
Okay. Okay.
Clear with this. Next one. So let's say we have a vehicle here. Vehicle is going with 36 kilometers per hour. I hope everyone knows how to convert 1 kilometer per hour. So kilometer is 1000 meter and 1 hour is 3600 seconds. So this would be 5 by 18 meters per second. So this car, the driver, when he saw the signal and he applied the brakes, the car stops in 20 meters. So this distance is called a stopping distance, meaning the distance you travel when you apply brakes. This is quite important. Matlab, for vehicles, for example, if you look at our, this is what actually happens with the local trains. If someone suddenly comes in front of the train, the driver can't stop the train. They have a minimum stopping distance. So movies mein hota hai na, the hero is running on the track with a red flag, stop the train karke. In reality, the train will hit him and take him to the next station. So hero dies, movie gets over, and the end. So that is the thing. But it's very difficult because if you stop the train too fast, there is a chance the train might derail and many people will die in the train. So now it's like a compromise. You want to kill one person, or there is a doubt that you might kill more people in the train. So there's an optimal speed. You can't do anything about it. So a bullet train requires a distance of 20 kilometers to stop. Meaning they start braking from 20 kilometers. But I think they can stop within a distance of 6 kilometers where they can stop. But they need at least 6 kilometers for stopping distance. So because bullet trains, when they hit a speed of almost 250, 300 kilometers per hour, they need that kind of distance. So this is the stopping distance. So this is the information you have. So the first question. So it's the same car. Let's say it's a Sunday, the traffic is little less and the driver is little going faster. The speed is 72 kilometers per hour. Then find the stopping distance. So you double the speed. The second part, let's say if the reaction time of the driver, this is one of the most important thing while driving, there is something called reaction time. Meaning this is the time interval between seeing something and reacting to it. This is the reason, if your friend who is sitting like 3 benches away throws a pen at you, you can catch it. But if the same friend is standing at one bench and tries to throw, suddenly you can't react. Even though the pen is coming, you're too late to put your hand to block that pen or something, to block something. Getting it? So generally a human reaction time, right, is around 0.4. If you're a very good athlete, it can be even 0.25. But normal people, we generally have around 0.4, 0.5 seconds. Meaning this is the time interval between seeing something and reacting to it. That means when the driver sees the signal, for 0.5 seconds, it takes time for the signal to go from the brain to the legs and then apply brakes. And this is the reason why people say don't talk on mobile while driving. Most people think if you're talking on a mobile, you can't drive properly. That's why you get into accidents. That's not the problem. Think like this. You're talking on a mobile and suddenly someone comes in front of you. Your brain cannot do multiple things at the same time. It does one voluntary thing at a time. So what the brain does, step 1, stop talking on phone. Step 2, see the other person. Step 3, send a signal. Step 4, apply the brakes. So that talking to the phone and doing that will increase by 2 steps, will increase your reaction time by another 0.4 seconds. You're getting it? So in that scenario, you will hit the other person at full speed. So basically talking on phone, you'll be distracted. That's what we call. So let's say this driver, right, is driving little rashly. If the speed is 108 kilometers per hour and his reaction time is 0.5 seconds. So at what distance should he see the signal so that the car stops at the signal when brakes are applied? If you see in cricket now, just think about it. The length of the pitch is around 20 meters, right? 20 meters, roughly, and the ball is traveling with a speed of 150 kilometers per hour. That means after releasing the ball reaches the batsman in less than 0.25 seconds. That means if the batsman is waits to see the ball and hit the ball will go away by then. You can't react to it. That is the reason, if you see, if you're anyone is a cricket player, you'll understand when you're batting, right? You actually look at the bowler ka hand and the point of release, and based on that estimate, you swing the bat. If you wait to see the ball, by the time the ball will already go, you won't be able to react to it. And that is a problem. It is very difficult to play swing bowling because the ball, after hitting the ground, it will swing. So the trajectory which you thought the ball will come, it won't be the same trajectory, so the ball will miss. So reaction time is time interval between seeing an event and reacting to it. Yeah. Let's see how to do. First one is easy. I think, yeah, some people did get answers. Right, Anshahana, Ignajit, Surya. No, that's not the answer. Let's see the first one. So the vehicle is traveling with 36 kilometers per hour. That's actually 10 meters per second. The vehicle stops here, 20 meters. So we are using v square minus u square is 2as. So that is 0. 10 square is 2a 20. So in the second case, you are traveling with 72 kilometers per hour. That is 20 meters per second. Eventually, anyways, you're going to still stop. So now your formula will be 0 minus 20 square is 2a, let's call it x. Divide them. Minus 10 square minus 20 square is 2a 20 by 2ax. We end up with x is equal to 80 meters. This is the mistake drivers do. They think, since my speed is doubled, I need stopping distance double. In reality, it became 4 times. So we can have a general formula for this. And this is what happens. You apply brakes at 40 meters and you'll overshoot the signal. Because human minds, right, we always think everything is linear. If you think, if I put x effort, right, and if I got a y result, if I put 2x effort, I'll get 2y result. But in reality, if you put 10x effort, you'll get 100y result. Things go non-linear. Human brains are unable to understand. It is like, imagine like this. You open one coffee store, you'll make some profit. You make 10 coffee stores, the profit will be much higher than single one. Reason, if you have 10 coffee stores, right, you can buy the supplies in bulk. The cost will go off. Logistics will decrease. That is the whole game. That was the reason Zomato was not, not profitable for so long. Now, since everyone started ordering everything from Zomato, it suddenly started becoming profitable. So stopping distance, if you see, v square minus u square is 2s. So finally you stop. So minus u square is 2as. So we get s is proportional to u square. There. So if your speed doubles, distance becomes 4 times. Speed triples, distance becomes 9 times. Check it out. This is the first part. What about the second part? Now we have a reaction time also 0.5 and the speed is 108. Shit. 1005. The driver will die, Ray. You're running a bullet train. 205 भी आंसर नहीं है. 60.5. अरे लॉजिक सोचते हैं. When you went with 72, you needed 80. If you go 108, shouldn't it be more than that?
No, sir. It was the time I see. Sorry, sir.
Okay. No, don't be sorry now. Why do you guys say sorry for everything? You will do a goof of lot of mistakes in class. Don't say sorry for everything. Solve. If you guys don't do mistakes, who will do in the class? I also will do sometimes, but yeah. Answers, let's see. So let's say the driver sees here T0. So at this point, the driver sees the signal. But remember, it will take him 0.5 seconds to react. Means he won't apply brakes. Brakes will be applied after 0.5 seconds from now. That means you're still traveling at full speed. And this is the problem. If someone comes in front of you, you'll hit him at full speed. So in this process, you have gone till here. Let's say T is 0.5 second. Your speed is 108 kilometers per hour. That is 30 meters per second. Means in this 0.5 seconds, you have traveled distance of 30 into 0.5, 15 meters. Your car went without decreasing the speed for 15 meters. So from here, 30 meters per second. Now the question becomes a normal question. This is your signal. And finally, you stop here. This is your stopping distance. We know S is proportional to U square. Since U became triple, U became 3 times. S becomes 9 times. Therefore, the stopping distance S should be 9 times 20 meters. So 180 meters. There's no need to solve also. So that means this guy saw the signal. For 15 meters, he didn't apply the brakes. Then he applied the brakes and the car took 180 meters to stop. So therefore, the total distance at where he saw the signal is 15 plus 180, 195 meters. Is this clear, everyone? That's it. You just have to add that extra 15 meters, the time when he didn't apply any brakes. Why don't we have to take? Because there's no acceleration, no, Jainil. If you didn't apply brakes, there'll be no acceleration only. Your diesel. When will deceleration start? Once you start applying brakes. But you will take 0.5 second to apply brakes. Clear, everyone? Any other confusions? So do remember, reaction time is something. So theoretically, right, the fastest reaction a human can have is 0.11 second. That is the limit. You can't be faster than that. That is the minimum time it takes for a signal to go from your brain to any part of your body. Because end of the day, how fast you react will depend on how fast your electric signals are moving between your muscles. So there is always a delay. Clear? So that's the last one for that day. So we have done with the horizontal motion today. So next class, when we catch up, we will do vertical motion. This time things will fly up and down. That will be a little more fun. And then we will throw things from buildings. That will be even more fun. Then we will hit some birds also. So we will do everything. We will throw stones into windows and buildings and for the greater good of society. So we will do all that stuff. Okay, so with that, we'll finish off with this. So we will see first any doubts in the class notes. Then we will see the paper cut doubts. Right? If